Hello and welcome to this week's asynchronous assignment and lecture. I recorded all of this before I had my second cup of coffee and it just didn't have the right energy. I'm re-recording it as a caffeinated human being. Okay, so before we get into this really exciting, adorable slide deck and lecture, we need to have a couple things downloaded. The first is going to be GitHub Desktop. So we can just type in GitHub Desktop, download in our Google bar there. Click it, download for your operating system. Once this finishes downloading, we can open it right up. So now in our downloads folder on our file system, we have this application. I'm gonna double click on it. It's probably gonna ask me to make sure if this is something I wanna do. I'm willing to take that risk. I'm gonna say open. And then when I do, it might also ask me to throw it in my applications folder since GitHub Desktop is an application. If not, that's okay. Oh, yep, move and restart. Okay, so that's how you do it on a Mac. It's gonna be really similar doing it on a Windows. Okay, next. The next thing that we're going to do is we're gonna make ourselves a GitHub account. So let's just type in GitHub. Let's go here. Takes us to this page. Whoop. This page. Whoop. This page. And you want to sign up for GitHub. So enter your email address, click sign up, walk through those steps. I already have an account, so I'm just going to sign in when we go through the lecture. And then once you have all that set up, there is one more thing that you might need. For GitHub Desktop, you're going to need Git. So type in Git, download. I know it's confusing. There's GitHub and Git, but we'll get into why they are different. Click on downloads, and then you can click for Mac OS or Windows depending on your operating system. For Mac OS, there's a series of steps. Just follow those step by step. Don't be intimidated. Just do exactly what it says. And then for Windows, same thing. I think it's as easy as just clicking right here, and then there's an executable that gets downloaded, and then you make sure all of that gets put into your computer. Okay. If you have any trouble with these three things, let us know and we'll get you set up. Otherwise, let's jump into it. This lecture is on GitHub and the concept of version control. It's one of my favorite lectures because it is a super powerful, amazing tool that lets you collaborate and build code together in a very safe way. So we're going to go over what version control is, why it's so cool, what Git versus GitHub is, what GitHub Desktop is, right? There's so many Gits. How we will be using GitHub and GitHub Desktop in this class for project 2. We're just going to practice it, see if we can get our brains wrapped around it. And then we are going to have an activity that will be due. There will not be a submission for this activity, and you will see why in a bit. So we're going to come back to this example a bunch as we go through this lecture. So picture this. You've already logged a ton of hours in this game that you've played. You're like very invested. You end up walking into this room that's filled with health potions and supplies. You have all of your health. But as you do, something doesn't feel quite right. The kind of adventurous, upbeat music makes a transition into some boss battle metal. So picture this in your head. We're going to come back to it. But first, what is version control? you've got this little version control assistant. His name's Gideon. He's really cute. He's kind of like Clippy, you know? Does anyone remember Clippy? It's like the little paper clip that popped up on Word and gave you like tips and tricks. If you don't, just ignore what I said. Gideon is your version control assistant, and what he tells us is that version control is the keeping track of changes in your code over time. So let's go back to that example. You feel like there's about to be this boss battle and you might die. And if you die now, you could have to start the whole game over, unless you smash that save button. Version control is like saving so that when you die, you can go back to that moment in the past in the game when you were like not dead, you were alive. So if you save a version of that game in that moment of time, like have a file that's saved at that moment in time when you're not dead right before you fight, that's like kind of the gist of version control. So why is it cool? Well, Monroe's gonna walk us through like providing context, answering those why questions. This slide is so cute. They're so cute. So look at those little fingers. So why does version control matter? Why is it cool? Well, being able to return to that moment in time when your health is high and you have potions at your disposal and you haven't been defeated by a big boss is like pretty invaluable. Like, can you imagine feeling all of those hours that you put into getting to this point were like completely wasted? Be heartbreaking. And it would just make you want to throw away the game and walk away from it. And that's not what we want. That's not what we want in code. So version control lets us time travel just like it would in the game, right? We die, but we get to go back to this point in time when we weren't dead, and it doesn't make us start at the very beginning. So same thing with code. Let's do an example, something we're familiar with. Let's say we have some code, and it's written so that this PIR, or motion sensor, turns on an LED if motion is detected. So if motion is detected, then turn on the LED. But let's say, we spent some time making this code function and it works really well, but we want to like level up our hacker status and we want to add a button to the mix for some reason. Maybe you want to press the button and have the lights kind of like rotate through each color. Well, that's amazing. We always want to encourage you experimenting with code. But what you might be feeling is that you spend so much time making sure that the LED and the PIR sensor code is correct that you're worried that you're going to make a mistake and like screw everything up. And so you're kind of thinking like, I don't know, we put all this time into it. Like, I really don't want to ruin anything. I should probably just keep it simple, stay with the sensor and the LED. False. Experiment. Mess things up. See how it goes wrong. Fix it. And the reason we can do this is because we use version control. And version control is like our safety net. No matter how bad we screw something up, we can always go back to a different moment in time when everything was working well. And we probably are going to learn a lot as we start messing things up. This is this concept called failing safely. Failing safely is kind of like just feeling like you can mess things up. I hate to be redundant, but that's what it is. Coding is all about like messing things up, realizing how and why things got messed up, and then making more mistakes. As you make mistakes like those if-else statements and those while loops, it'll all start to come together. How you can use functions and variables. Like, the best way to learn is to mess things up and see what happens. So version control is that safety net that allows you to do that. Version control is also very cool because it allows you to create code collaboratively. So imagine, Gideon, our cute little Gideon, is working on their code for their Arduino and their circuit at home, and they're on a team with Monroe, who has her own Arduino and her own code at home. But they want to be working on the same project together and kind of stay up to speed with the current state of the project as they keep kind of chipping away at it. That's why version control is cool. And Git and GitHub is how we're going to be using version control in the second project. So let's talk about what are they and what the difference is. Git is like a system, or like a set of actions that we can use for code management. We can track changes and work together. So GitHub is this website where you and your partners or your teammates can find the collaborative code and the changes made with that code, in that code, over time. That's where everyone can access it, on this website called GitHub. It's the thing that you made your account in before this lecture. Thank you, Monroe. We need GitHub so all of our teammates can see the changes that you made on your computer, because they're not sitting right next to you. They could be at your own house, their own house. Okay, so what about GitHub Desktop? We talked about Git and GitHub, but why does GitHub Desktop have to enter the picture? Well, we already went over how to download it, but how and why do we use it? So GitHub Desktop is an application on your computer that can let you use GitHub and Git using a graphical user interface, or a GUI. So do y'all remember the difference between a GUI and a CLI? Reflective pause. So the GUI is how you can interact with things with like icons, intuitive formatting. While command line interface, there's a little bit of a learning curve. You type commands into your terminal and something happens, right? Like removing a file or copying a file. The GUI just lets us kind of like use more intuitive formatting to do those same actions. So we're using GitHub so that we can just use a GUI. So it's a lot easier. So in order to understand and jump into using GitHub and GitHub Desktop, we need to kind of go over some terms first. So the first big thing is, what is a repository? So before we can understand a repository, let's get on the same page about what our project would look like. So think of your project like a folder in your file system with lots of files and subdirectories. For example, let's say Monroe and Gideon are working on a project together called AET Project 1. That would be that root folder. And then they would have 2 files in that root folder, and that whole entity is their project. But a repository is all of that, all of your files, project files, and one more thing on top of that. It has each file's revision history. For example, let's say our project on Monday looks like this. Maybe Monroe's code file is empty and Gideon code's file is empty. But then on Tuesday, Monroe completes her code for her LED and her sensor. And then Gideon's code is still empty. So Tuesday's project looks a little different. And then Wednesday's project is like Gideon finally uploads their code. And now we have Monroe's code and Gideon's code in this project, and the code has been improved upon. So revision history is like all of these steps that the project took to get where it currently is. So let's just kind of go over that one more time in terms of the example that we used. Maybe we make a save right before we fight the boss. Right after we defeat the boss, we make another save. And then right before the next battle, we save again. So anytime there's a moment where we might die in this video game, like in between these points, we go back here instead of all the way at the beginning. Same, like if we die at this point, we go back to this moment when we defeated the boss, not right before you fought the boss, so we don't have to fight him again. Kind of like these save files here. They're all dated, right? They're all saves at a certain point in time that we can go back to. So there are 2 types of repositories that we'll be going over. There is a local repository, and there will be remote repositories. Local repositories are where like you as a team member can make changes. So imagine you have a file on the Arduino IDE and you decide to make some change. Maybe you just like make some comments, or you add your name to the top in a comment, or maybe you change the logic entirely. You do that in the Arduino IDE still, and then when you save it, those changes get saved to your local repository. It just lives right on your computer. And you'll see this when we walk through an example. So same with Monroe's. The difference is that one lives on Gideon's computer, the other one lives on Monroe's computer. A remote repository is on github.com. Both Monroe and Gideon can access this repository. They can fetch updates to drag that current state of the project into their local repositories so they can keep building on it. Kind of make sure that like everybody's up to date with the current state of the project. So how do we get a repository from GitHub to your computer? Well, if Gideon has gone through the steps to get their project on GitHub, Monroe will need to clone that repository to get it on her computer so she can add to it and make changes. All of this is pretty abstract. It's pretty confusing because we haven't gone through it step by step. So that's what we're going to do right now. So Gideon made a project. He made a project on their own computer, and the folder is called AET project. And it's got Gideon's folder with like gideon.ino in it. Let's just go ahead and be Gideon right now and do this. You can double check to make sure that your GitHub account is hooked up properly by getting to preferences and making sure that you are in the correct account. So we want to click File, New Repository. Now this repository name is like the name of the collaborative project. So maybe we just want to do AT Proj, like in the slides. You can add a description. So Gideon and Monroe's project. Now we need to choose a location. Where is this repository going to live on our local computer? Well, I'm going to do desktop, but I think that you guys should probably put it in the folder that you use for this class. We want to click on Initialize this repository with a README, and then we want to click Create Repository. So now we have this repository. It's empty. There's no files in it or anything. Let's go ahead and just publish this. You know, eventually we want to have online on github.com those files that Gideon made, but for right now, let's just publish a repository and see what it looks like. So I'm going to click this. We have a name for it, AET Proj. And we're going to unclick Keep the Code Private. And we're going to click Publish Repository. Now I'm going to show you something really cool. Let's go to github.com. I'm going to sign in as Gideon. And now when we go to this top right icon, click Profile, you'll see under Repositories, it showed up online. How cool is that? It's wild. It's so awesome. So we can click on this. But all we have right now is this README file, and it just says AET Proj, Gideon and Monroe's project. We need to change that. Gideon wants to make some files. So let's let Gideon make some files. Let's open up our Arduino IDE. Once we have this open, let's make a brand new sketch. File, New. We are going to save this blank sketch. We're going to name it Gideon because it's Gideon's file. We're going to find where our local repository is. I saved mine on the desktop. You probably saved yours in your M&T folder. I'm going to click here and I'm going to save it in this folder, this local repository. I want to show you what GitHub looks like right now before I save it. It says no local changes. there hasn't been any changes. We haven't added anything to this repository. But when we save it in this folder, guess what happens? Let's give it a second. All right, now we saved it in that folder. Let's reopen GitHub Desktop. What? How did it know? That's so magical. It looks and it says, hey, there's some changes being made. There's this whole new file called gideon.ino in this folder called Gideon that popped up in our repository. We noted, we tracked those changes. But there's another step we have to do to make sure it gets on github.com, because if we go to github.com, it's still not there. That's no good. We want it to be there because we want Monroe to see it. So now we have to commit those changes in order to save them into our local repository. That can be kind of confusing, but just follow the steps. So the most important thing when we make a commit, when we make a change, is that we want to make like very small changes, right? So this small change was that we just created the file. So the commit can say created Gideon's file. Don't worry about the description, just put the message right here. Click commit to main. And then this pops up. Push your commits to origin remote. Just click the button. Don't worry about it. And then when we go to github.com, guess what shows up? Your folder with the gideon.ino, and you can actually see the code online. So Monroe can see this. It's so cool. It's so cool. So Gideon's local repository looks like this, but the team's remote repository looks like this, or looked like this. So Gideon had to create a local repository on GitHub Desktop, create a new sketch in Arduino IDE, save it into their local repository, and then commit changes with a message in GitHub Desktop. Then what Gideon did was publish that repository and push those changes to the team's remote repository. The team's remote repository now looks like this. So cool. So very cool. Now let's invite Monroe to the project. Because Monroe's local repository currently looks like this. Even though Gideon has published the team's remote repository, Monroe doesn't have it on her computer yet. We gotta get it on her computer. So what does Monroe have to do? A couple things. Monroe has to fork Gideon's repository. That means creating a copy of it on her own GitHub account, and then clone that remote repository on her GitHub account so she can have it as a local repository on her computer. Let's walk through those steps together. So now I am Monroe. I need to sign out of Gideon and do a little character change here. So here's Monroe's profile on GitHub. There are no repositories. But Monroe knows that Gideon's username on GitHub is GideonAET. So we're going to type that in and we're going to click all GitHub. And you can see all the way down here in users, we can find Gideon's profile. So we're going to click it and we see that Gideon has this repository. So there's a couple things we need to do. First of all, Monroe is so excited. What did Gideon do? Oh my God, Gideon's so talented. So we need to go to the project, so GideonAET/AT proj, and then we need to fork it. We need to fork it. So let's fork it. I clicked on this fork button here in the top right. It says forking GideonAET proj. It'll take a second. Now it is forked. What does that mean? It means that on Monroe's GitHub account, she now has a copy of that repository. And you can see it here, forked from Gideon's Gideon AAT/AAT project. So now Monroe can make changes and experiment without messing with that original project that's managed by Gideon. But it's still only on github.com. It's not on her computer yet. So we have to do some stuff. I have to do a character change here. So I'm not Gideon anymore. I am Monroe. I need to do this. File, new repository. Oops, no. I need to do this. File. Monroe's gonna need to clone the forked repository. Let's go back over here to github.com. We're going to click this green button, code. We're going to copy this link. We're going to go back to GitHub Desktop, and then we can paste it in there. The reason it's mad at me is because I need to choose another location. It won't be mad at you because you're not pretending to be two people like I am right now. But let's just go ahead and throw it in desktop. And then let's name it like just AET, Monroe. So let's clone it. So the cool thing here, let's just hit continue. The cool thing here is that now in Gideon's file system, we have that local repository. It's called AET Monroe. And it's got Gideon's stuff in here. So like Monroe could open Gideon's file and be like, hey, you made a mistake. I'm going to fix this mistake. But that's not what Monroe wants to do. Monroe wants to add her own stuff so it's not the Gideon show anymore. So Monroe is going to click File New. She's going to open this blank sketch. She's going to save it as Monroe. And she's going to save it into her local repository. So click Save. We can see it pop up in her local repository here on Finder. And then when we go back to Monroe's GitHub desktop, those changes pop up just like it did for Gideon. So we can say created Monroe file, commit to main, push origin, and then now on Monroe's GitHub, we can go to Monroe, repositories, AAT project. This copy that she has now has both Monroe and Gideon's files. But here's the thing. On Gideon's project, which Gideon is like that project owner, manager, it still only has Gideon's file on there. So Monroe has to do one extra step to make sure that those changes are acknowledged. But let's go back here real quick. So Monroe just forked Gideon's repository. She's got a copy of it on her own GitHub account. She cloned that repository, so she has it now as a local repository on her computer. Like that. And now both Gideon and Monroe have that same version of the project. All teammates are current and up to date, great communication. This project feels like it's going to be super successful. Then Monroe made some changes and she committed those changes. Right? She's like, I'm sick of this being the Gideon show. I'm going to make Gideon's or Monroe's folder, pretend this says folder. And she committed those changes with a message, which is such a nice thing to do as a teammate. You always want to be putting a message of what your changes meant or what they were in your own words. And then she pushed that commit to her forked repo. So now her forked repo goes from looking like just Gideon show to everything, right? but there's an issue. It's just on the forked repo. In the team remote repo, like, still looks like the Gideon show. So Monroe has to make a pull request. Let's walk you through how to do that. So we're still Monroe. Let's go to our profile. Let's go to our repositories. We can say AAT proj, forked from Gideon. We need to click contribute because we want to contribute as Monroe to the main project. And we're going to click open pull request. And then we're going to click create pull request. So that's all Monroe has to do. That's what we just did. We created a pull request. Then Gideon has a job. So let's be Gideon now. So when Gideon looks at Gideon's own repositories, which they can click right here. Let's open that repository up. It's still the Gideon show. There's a bubble that says 1 that pops up next to pull requests. Let's click on that. So there's this pull request. It's like Monroe saying like, hey, is it cool if we put my changes into the main project? And as Gideon, we need to approve it. So we're going to click this button called merge pull request. And what we're doing is merging those changes that Monroe made into the main project that Gideon kind of manages or controls. So now when we go to that main project, it has Gideon and Monroe's folder. So let's visualize this. Monroe has this forked repo, makes a pull request to Gideon's kind of like managed remote repository. Gideon then approved it and merged those changes that Monroe made. And now the team's remote repository is up to date. Gideon still has a outdated version of the project on their local repository. So they're going to need to fetch and pull the changes. Here's what this looks like. So let me open. Now we're Gideon again. Gideon's folder is AAT proj. It still only has Gideon's folder in there. So now let's go to Gideon's GitHub desktop. There's this button up here called Fetch Origin. It's going to grab those changes that were on the remote repository. And then we're going to need to pull them so we can see them. Oh, hold on. Da, 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 da. So right now we're in Monroe's. Sorry, it's kind of hard to like jump back and forth between two people. So now we're getting AAT proj. We need to fetch the origin. Then this thing pops up and it says pull 2 commits from the origin remote. Seems confusing. Let's not worry about it. Let's just hit this blue button. Now, when we are in AAT project, which is Gideon's folder on their computer, we see there is a Monroe in a Gideon folder. How cool is that? How cool is it that you can make changes, show them to your friends can take those changes, improve upon them, or make their own files, push them back up to GitHub, and then you can keep, it's like ping pong. You keep passing the version of the project back and forth, and it gets better and better every time there's changes. And then if there's a mistake that's made, that's okay, because you can always go back to a different point in time. So Gideon fetched and pulled those changes, and now Gideon has the up-to-date version on their local repository. So let's just kind of review some terminology we use to kind of drill it in. And then this is always something you can go back to as you're using GitHub for your project. Number 2, not this project. Local changes are the changes that you make on your own computer. When we commit, it's this button on GitHub Desktop that we use to save our changes to the local repository. We need to do this before we push. When we push is how we get our changes that we made on our computer to travel to GitHub so your partner can grab them. Origin, it's the same thing as remote repository. Fetch origin is how you can get the changes another teammate made on your own computer. When we fork a repository, that means we make a copy of it so it lets you experiment without affecting the original project. You copy it on github.com. When you clone it, you take your forked remote repository on github.com and you pull it into your file system. It's like the second step of how you get a published repository onto your computer. Messed up. A pull request is when you ask the teammate who kind of owns that remote repository, so in this example it was Gideon, if you can merge your changes into the main project. They approve it, thumbs up, now your changes are part of the main project. Merging is how you put changes from a forked repository back into the main project. So merging is something that happens when the code owner, merging is something that happens when the repository owner approves the pull request and it merges those changes into the main project. So it's kind of this cycle. Gideon makes changes, they commit them, then they push them to GitHub. Monroe then has to fetch those changes and pull them so that she can stay on top of the current state of the project. If this isn't done continuously, it gets kind of messy. So you need to make sure you're constantly fetching and pulling changes from the current state of the project so that you're not working on an out-of-date project. So let's try it out. So we're going to go to that same remote repository that Gideon has published. You're going to find it by clicking here. It's got Gideon and Monroe's folder. And your job is to fork and clone the repository just like we did in this lecture so that you have a local repository on your computer. And you also have a copy of the remote repository, which is the forked action. Then you're going to create a fresh new empty sketch in the Arduino IDE, save it on your local repository, commit it with a message. That's how you get it to save on your local repository, and push those changes to GitHub. Then you're going to create a pull request that Gideon will approve, and those changes will be merged. And then we can come together next week and we can see what happens when Gideon approves all those changes. It's going to be really cool. For this assignment, there will be no submission, and it's because I, as Gideon, am the one who owns that remote repository on GitHub, and I can see who did it. Because you will have to create a pull request and you will make that folder your name. Let me just add this in the instructions. So you're going to name that folder or that file, that sketch, your name. And then I'm going to go through and see how many people made pull requests and then give you credit if you have. Cool. If you have any questions about this, you know where to find us. We're here for you. It's a lot to take in, but if you follow this step by step, then you're going to be A-okay. And remember that this isn't for Project 1, the one that you're currently working on. This will be for Project 2. And the reason that we're using it in this class is because GitHub is an incredibly powerful tool that's used in the industry as version control constantly. I'm sure some of you have already kind of started working with Unity. Check this out. Unity has published 642 repositories on GitHub. And when we say that certain projects are open source, it means that everything that we just went through as far as forking and cloning can be done on your computer. So we can take this, I'm not sure exactly what this code does, but it's a project that Unity's working on. I can open it with GitHub, clone it, It takes all of that code that like really smart, awesome hackers wrote, puts it on my computer. It's going to take longer because it's more code than what we just did. And then we can mess around with it, like professional, really cool level code. Like we can put it on our computer and mess around with it. And then we could like potentially make a pull request and be like, hey, Unity, I did this thing. It's pretty cool. And they can look at it and be like, shit, that was really cool. And then they can make it into the project. And now everything that's on GitHub is now on my own computer. How wild is that? I think that's all. This is going to be due Tuesday before class. Next Tuesday, not this coming Tuesday, Tuesday after. So you have a full week to do it. We'll see you on your cohort day.